Hello students, today we are in lecture number 32 of chapter 3. Okay, and this chapter is current electricity. Okay, my dear students, so the current electricity will start today. Current electricity. My dear students, this particular chapter you have started in your standard 10th. Okay, actually in this chapter what we'll study, the electric current. Who will be responsible for electric current? How we will get the electric current? We have finished our first chapter, electrostat, in which we have studied the charge is in rest, even in motion. Here we are going to study the charge in its dynamic state. Okay, actually we study in this chapter dynamics. Okay, dynamics of charge. Dynamics of charge, that is motion. Okay, motion of charge. In last chapter we have studied, my dear students, in motion, that is the charge can have the constant velocity or the variable velocity, but in this case charge produces electric and magnetic field. If it is accelerating, then it radiates some energy. Okay, so this one is actually about the dynamics of charge. What does it mean? The dynamic means the conduction electrons. Remember, conduction electron are responsible. Okay, are responsible for what? They are responsible for electric current. And the conduction electron, what does it mean? It means the electrons which are free. Okay, free electrons that are free in outermost orbit. Free electrons in outermost orbit. Remember, in outermost orbit, okay, of any atom. That electron are responsible for the electric current. Now it is very important, my dear student, to define the electric current. We are starting the current electricity chapter, so it is very important how you will define the electric current, which is the very simple. You have already given the definition, you have already learned the definition. The rate flow of conduction charge. Remember, rate flow of conduction charge through the conductor. Remember, again I'm telling you, the rate flow of conduction charge. Of course, we are talking about here the charge carrier as the electron. The rate flow of conduction charge through the conductor is called electric current. So if you will try to write it mathematically, here we are representing electric current by I. So thus can be represented as I is equals to, using the particular limits, a small amount of charge with a small time. If you leave the charge to move within that very particular time, this will give you the amount of charge, rate of charge. Okay, so here the I is dq by dt. Remember, and this particular is the instantaneous current. Remember, it is the instantaneous current. Okay, you can find also the average current through any conductor. What the average current flowing through the conductor. Now I that is the current we are having here, the Q by T. It is the amount of charge flowing per second, which is the electric current. It is the charge flowing through a particular area in particular time, in particular time, and that is the current. Of course, student, if you will write the SI unit here, the SI unit of charge will be coulomb and per second, which is also equivalent to the ampere. Okay, it is ampere. So we'll use the SI unit of electric current as capital A. This will be the SI unit of electric current, which will be considered as the ampere. Okay, my dear student. Now you can solve few questions that are very easy. Suppose if I'm giving you the charge, amount of charge, and the time in which the charge flows through the conductor or crossing the particular area, then you can find out the electric current. If I'm giving the number of electron crossing per unit, or the number of electron moving through any conductor and crossing it in 1 minute, 2 minutes, whatever may be the time, then you can find the current again. Okay, my dear student. So a very simple question. I'm going to write here the data and you can solve this is as your homework. Write down question. This question is how many electrons pass through a wire in 1 minute if current passing through the wire is 20 milliampere. This is your question. Okay, try to solve that question by yourself, my dear students. Okay, now next, here we have started the electric current. Now the question is what are the nature of current? How many types of current do you have to study, that you have to study in your course? So there will be 3 types of current, my dear students. Remember, there are 3 types of current you have to study in your course. Actually, the third type has been left out from your syllabus. The 2 types of current you have to study. One, it is called the steady current. STEADY, steady current. Okay, this is also called DC, direct current. Okay, this is also called DC, that is the direct current. Now the second one is alternating current or AC. Alternating current. Remember, in short I am writing here the alternating current. And the third one is transient current. Okay, or the transist current. The transist or transient. Here AC current. Okay, we used to speak alternating current, otherwise we write AC current. Here DC current, direct current, DC current, you will write here DC current, that is the direct current. Now this steady current you will find in conductor. Okay, this AC you will find in conductor even, and the electronic circuits. This transient current you will study, and it is found in inductor. Okay, inductor and capacitor. Okay, now DC, what will be the nature of direct currents? So I'm showing here direct current using a graph. If it is current and it is time, then in DC, that is the direct current. Okay, the direct current, it has many natures. The direct current, steady current can be converted. This direct current can be categorized in 2 forms: steady current and fluctuated DC current. Here I am drawing the graph of steady DC current. Steady, it means its magnitude not going to be changed. This is the steady DC current. Okay, steady DC current. why this DC is named DC? Because it has only one nature. Along the positive cycle, this current is moving. Okay, if it will change its magnitude, that is also the DC, but that will not the STD. But this is STD DC current. If you are making the diagram, this one, this is the current, and this is the time, and this one is the graph. Of course, this is also the DC current, but this is not the steady current because its magnitude changing everywhere, but it is moving, although in one direction, that is the positive direction. That's why this is also DC current, but that is not the steady current. This is the steady current. Now AC, what will be the nature of AC, my dear student? So AC, nature of AC looks like this one. We will study in detail about this AC, okay, in our course of standard 12. The peak value of alternating current, this is I naught. This I naught is considered the peak value. Peak value, that is the maximum. But current changes its magnitude, and this one is like it goes on positive cycle as well negative cycle, but you can see the magnitude changes everywhere, and you will find the equation of such current as I is equals to, which is changing with time, as I naught sine omega t. If you remember this omega, you have a study in rotation chapter. This will be the I naught peak value. This could be 0. At this point the current is 0. At this point this will be maximum. At this point the angle will be pi by 2, and sine pi by 2, this omega t will give you the pi by 2. Okay, I'm not confusing you, simply just get overview. We will study in this in detail. Here the sine omega t can be also written as the sine omega is 2 pi f. I hope you must remember, and this is the IT. So this will be the graph. This is called the alternating current. This is the nature of, or the graph of, alternating current. Now transient current. Transient current you have to study in capacitor or inductor, that I'll discuss in AC circuits. Okay, my dear student. So these are the types of current you have to study. There are 3 types of current you have to remember. Now the next thing which comes in our mind, so what and how can we measure, and which measures the electric current actually? Okay, which measures the electric current? All the things I am dealing over here, you have to write in your notes, that are very important for your examination point of view, my dear student. So the electric current measured by 3 things basically. Otherwise there are number of things that will measure the electric current. Electric current measured by, remember, 3 things basically. It is 1, magnetic effect. It is measured by magnetic effect. Magnetic effect that we have to study. The second one, which is the very important, it is the chemical effect. Chemical effect, okay, and third one is the heating effect. This measures the electric current, okay, the heating effect, my dear students. Magnetic effect, chemical effect, and heating effect, etc. Because there are few more effects that can measure the electric current, but we use electronic device to measure the electric current as ammeter. Okay, ammeter used to measure the electric current. Now, my dear student, there should be a question come in your mind. So what is the direction of electric current? Remember, this electric current, that is I, is a scalar quantity. It is a scalar quantity. It has magnitude as well direction. Sir, If it has magnitude and direction, then it should be vector quantity. No, my dear students, it has magnitude and direction, but for vector quantity, the condition is a quantity should have magnitude, direction as well. It should obey the vector laws of addition, but this electric current does not obey the vector law. Suppose one conductor I am giving you in this way. Okay, the one conductor. The 5 ampere current is flowing through this conductor, ampere the SI unit. Now, two conductor is being connected from here. Okay, and if 2 ampere will flows in this direction, then what will be the amount of current here? The 3 ampere. Have you ever seen while changing the angle between these two conductor, the amount of current which is going in this directions changes? Answer is no. Here the 2 ampere going and 3 ampere going. If you will arrange the conductor in this way, even the 120 degree, it doesn't matter, and the 5 ampere current will break in two parts in same way, that is the 2 ampere and 3 ampere. So there are different factors on which the current is depending how much current will move in this direction and in this direction. These are the electrical resistance that we will discuss. But you have to remember I, that is the electric current, is a scalar quantity, although it has magnitude as well as direction, but it does not obey the vector law. Remember, okay, the laws of vector addition. That's why we used to say it is a scalar quantity. Now, my dear students, we'll discuss what should be the conventional direction of current. Okay, the conventional direction of current. Conventional direction of electric current we are going to discuss now. What should be the conventional? Actually, the direction, why we study the electric current? Because electron flows. Okay, electron flows. Responsible charge carrier for electricity in different things will be different. Okay, we'll study, but the charge carrier as electron, it flows. Suppose if charge is, that is the electron, is moving this direction, this is the direction of velocity of electron. Okay, if this is the direction of velocity, then current will flow opposite to the motion of electron. Remember, this is the conventional direction. If you talk about the positive ion, okay, if it is the positive ion that is also responsible for the electric current, we'll study. If positive ion moving in this direction, this is the direction of velocity, then current will be in this direction also. Remember, it means conventional direction of current we study opposite to the flow of electron and in the direction of flow of positive ion. So this is the conventional, okay, this is the conventional direction. Now, sir, what you were talking about, what is the charge carrier? So look at here, the current and charge carrier. I am telling you. Let me rub this. Current and charge carriers. Current and charge carriers. Okay. In metal, that is the conductor, in metal, that is the conductor, remember my dear student, there will be only electron. Okay, in metal, free electron. What is that? Free electron or the conduction electron. Free electron. This is also called the conduction electron are responsible. In semiconductor, in chapter 14th, you have to study semiconductor. In semiconductor, electron and holes. Okay, electron and holes. Electron, that is the negatively charged. Hole is the space, positively charged. That will study in very detail. Solution. In solution, like the chemical solution. Okay, in chemistry you used to study about the solution. In solution, okay, what are the charge carrier? that are responsible for electric current. So that are the free ions. Remember, that are the free ions. So in metal, it is the free electron, that is the conduction electron. In semiconductor, electron and holes. And in solution, free ions are supposed to be charge carrier that are responsible for electric current, my dear student. Now, my dear students, we'll start the next topic, okay? And that next topic is drift speed. Actually, that particular topic will speed up this chapter, okay? And it is the drift speed or the drift velocity. Drift speed. Okay, my dear student. So, drift speed, actually, suppose this is a sample of conductor, okay, through which we are studying here the electric current. Now, the drift speed actually give you the concept. Suppose there is an electron inside the conductor. There are number of free electrons, as you know, inside the conductor. If there is no electric field, what will happen? If there is no electric field, electron will move here and there randomly. It moves here and there with their own speed randomly. And who is responsible for their motion? So the energy is thermal agitation. Due to thermal agitation, they move randomly here and there inside the conductor. But as soon as we apply voltage that cause electric field within this conductor, due to that electric field, electron starts moving in particular direction. Electron compelled to move in a particular direction. If we are applying positive and negative, it means the direction of electric field will be in this direction. So what will be the direction of force? We know that if any charge placed in electric field, this is the electric field, okay, and any charge Q is placed in electric field, it experiences a force. How much forces will it experience? So it experiences Q times E. So this electron, since there are a number of electrons, this electron will start experiencing a force, and due to that force, this electron will move opposite to the electric field. Electrons start moving in this direction. But there are a number of electrons, and electron get collides, okay? It get collision with the other electrons. And due to that, the direction of electron, the direction of motion of electron, it changes, okay, after each collision. Suppose this is the direction of electron. This electron start moving this direction, but it get collision, and in this way electron is moving, okay. You can see this electron start moving in this direction, but due to collision it move this direction. Due to heavy collision, it moves in this direction, and randomly it moves in different direction. And finally, after number of collision, it drift from this point to this point. Actually, my dear student, electron move with the high speed, okay, it moves with the very high speed, but it drift with very low speed. Remember, it drift because number of collision takes place in very small interval of time. That's why it collides with the electrons, and it moves very high speed. It moves very high speed with very high speed, but it drift with very small speed. It looks like that it travel a certain distance in very small time, like the you can say the 10 mm in milliseconds it travel, like this one, okay, actually. And this is the very small speed. As soon as you switch on the fan, if only one electron responsible for the electricity, you can find it starts, but the effect of that motion of electron you are getting. That's why that fan starts very instantly as you switch on the fan. If this particular concept, the drift speed, will be responsible for the switching on the fan, then you will find after switching on the fan, you will get the electricity goes to the fan after few days, okay. So the speed of electron are very high, but the drift speed of electrons are very less. You can write the definition of this drift speed, my dear students. Actually, the electron moves randomly, okay, within the conductor and get collision with different electrons. So the definition you can write: under applied electric field, electron moves along the conductor and get collision with different electrons. The average velocity attained, remember, the average velocity attained, the average velocity, remember, the average velocity attained by electron is called drift speed. This is the definition of drift speed. The average velocity attained by electron is called drift speed. Remember, again I'm telling you, electron moves very high speed, but it drifts very low speed, that is very slowly. Now my dear student, a step by step I am telling you how this particular electron drifted inside the conductor. What happened? First we apply electric field, okay, then it experience a force, okay, then it start accelerating, then what happened? It get collision, then what happened? It again, due to collision, become in rest. It stops momentarily, but it has not to be in rest for all time, because electric field continuously applying, so it starts moving again. Due to this one, it starts moving again. It means changes velocity, changes its velocity, and due to this change in velocity, remember, due to this change in velocity, after each collision it attain an average velocity, and that average velocity is called drift velocity or the drift speed of conductor. This particular stepwise explanation will give you the mathematical expression of drift speed, my dear student. Okay, so we are going to derive here the expression of drift speed, okay, of electron in any conductor. Now my dear student, here this is the question of examination also. For example point of view, we will derive this one, expression of drift speed, okay, mathematical expression of drift speed, okay, will represent by VD, drift speed or the drift velocity. Suppose, my dear students, we are having a sample of conductor, this one, and we apply a voltage. We have given a voltage which will provide electric field. We are considering an electron, okay, an electron. If this is the direction of electric field, the electron will drift towards this one. This is the drift speed, Vd I am writing. Now what are the simplest thing that you can consider for the derivation? Under applied electric field, under applied electric field, what happens, student? Under applied electric field, electron will experience a force, okay, you can write here, electron experience a force, and that force can be written as how much? That F can be written as Q times E. Remember, I am not writing here the direction of the force and electric field. Remember, it would be the opposite to each other. If electric field in this direction, the force will be in this direction, of course, minus E. I am considering here the magnitude only. Okay, my dear student. Now, QE, remember, the charge of electron, we can write E, electric field E. And what does this force do? Actually, this force accelerates the charged particle, that is the electron, and the electron having the mass, suppose M. Okay, suppose M is the mass of electron, okay. Then what will be force experienced by that electron? Due to this force, it will be equivalent to the mass times acceleration, okay. In classical mechanics, we have studied ma. Now A can be written as E divided by m. This is the acceleration. Now, my dear student, what will the acceleration we can write here the acceleration can be written as the dv over dt, the rate change of velocity. Here the velocity changing as we discussed, and it is E by m. We can also write this dv is equals to E over m times dt. The simplest derivation, the simplest way. Remember, my dear students, I am deriving here. So the dv, now the important thing, we are putting here the limit. Try to be concentrate over here. Now the limit, when we start switch on this potential, the time was 0. Okay, the time was 0, and the velocity acquired, it is suppose 0 initial time. After giving, remember, we are considering the velocity in the particular direction. That's why we are taking 0. Otherwise, the electron does not attain 0 velocity even at time equals to 0. But in a particular direction, we use a velocity 0. Now, as the electron start moving, we know that it will not move straight. It moves randomly. It means it will take time to come up from here to here. Suppose the very elemental sample we are considering, and for very small collision if we are taking, and that time, that is the average time, if there are n number of collision and the time it is t second, then average time will be t by n. If that time is represented by t, that is the average time, and that time is called the time of relaxation. Okay, in that time t, from here to here, the time taken by electron is t, that is the tau. We are representing with the tau. And this attain a drift velocity vd, my dear student. Okay. Now, if this is vd integrated by, this will be the vd equals to e tau over m. And this is the drift speed. Okay. This is the simple equation of drift speed, that is the drift speed attained by the electron. Now about this tau, that is the time of relaxation. Time of relaxation. What does it mean by the time of relaxation? So you can write the definition of this time of relaxation, my dear student. The average time, okay, average time between two successive collision. It is the average time between two successive collision. You can say the average time to just move the particular sample of the conductor. So this tau is the time of relaxation, and it is the average time between two successive collision we are considering here. And this is a particular the simple derivation of drift speed. Using that particular equation, we will study in next class about the current density, my dear students. Okay, so this is all about current electricity, the first lecture, my dear students. Thank you very much.